I guess I'm audible. All right, super. Do we want to wait another minute to get started? Because it's 11. Okay, I can probably get started right now because. So anyway, my name is Shyam. I'm a staff software engineer working at the Qt company for the Qt for Python team. My today's session will be about simplifying your C++ application, bridging Qt with Python and beyond. Short emphasis on the term bridging because I need a quick show of hands. Who was here at the first keynote yesterday where Qt Bridges was presented? Anyone? All right, super. For the others, Qt Bridges is this new project that we have been working at the Qt company. And the idea, what we believe with Qt Bridges is that it's going to be the future of QtQuick development. In the course of my presentation, I will be showing you an introduction to Qt Bridges, specifically from the Python point of view, where we are at with Qt Bridges right now and how that differs from PySide. And I will also be showing you some other developments that we are doing at the Qt for Python team. So without further ado, let's get started. I want to start with what I believe are the ingredients of a successful framework, like Qt, Flutter, Electron, etc. I'm sure that many of you would agree to these points. The very first point is a strong and an active community. A strong and an active community is a key ingredient because a strong and an active community promotes continuous improvement. Technical excellence and reliability is also another key ingredient because that enables the developers like you and me to build trust in that GUI framework. 3 is developer satisfaction and ease of use. I want to focus a bit more on developer satisfaction and ease of use. What are the expectations of a modern developer? I'm a developer. I'm sure that many of you sitting here in front of me are also developers. What I expect from a GUI framework that I use is definitely cross-platform support. Cross-platform support is a given. It's a must-have. Rapid development cycles. When I develop when I develop an application in a framework, I expect to develop my application in rapid iterations, making use of all the tools that are available at my disposal provided by these frameworks. And third point is multi-programming language support. From henceforth, I'll be calling that multi-language support. Why is multi-programming language support important? Let me tell you a story. Many years ago when I was a student, few years ago when I was a student because I'm not that old. Few years ago, the very first programming language that I learned was C++. Things have changed. I'm sure that when you guys were studying the very first programming language you learned was C++. Modern developers are actually learning more modern languages like Python, Rust, etc. New developers are embracing modern languages. We all love C++. Most of you are C++ developers. But as you realize that the learning curve for C++ is quite steep. As such, frameworks like Qt should adapt. So how do you support new languages in Qt? I'm going to present to you with 3 different options. Option 1 is the first thing that comes to your mind, is to rewrite Qt in a new language. When you think about rewriting Qt in a new language, it immediately gives you a headache because it's going to be a massive effort. Why? Because Qt, as you know, has been existing for 3 decades right now. It's not just 3 decades of development, but it's also 3 decades of testing. So it's a massive effort. It also leads to a loss of maturity because all these 3 decades of optimizations in Qt are lost. When you rewrite Qt in a new language, you literally have to go back to the drawing board. You literally have to start from scratch. I'm sure that those 2 points are enough to convince you that this is a very bad idea. Rewriting Qt is not practical. Well, option 2 would be to create a language binding for Qt. For those of you who doesn't know what a language binding is, the language binding is the process of exposing a language in an API in one language to another language by a wrapper layer in between them. For example, PySide. Who here knows about PySide? Good. PySide is the official Qt Python language binding. So coming back to option 2, why is creating language bindings for Qt? It's much better than the first option because it preserves Qt's maturity and stability. Because any calls that you make to the language bindings get redirected to the Qt C++ code. It's an incremental adoption path in the sense that, it's an incremental adoption path in the sense that you can actually introduce this language binding into your workflow without disrupting the existing workflow for you. It's also a proven approach because PySide, has been existing for many years, is the official Python language binding for Qt. There is QtJumby as well. And the fact is that there are so many more language bindings for Qt. Even I realized there were so many language bindings for Qt the other day. Just go to the following link and you can see all the language bindings for Qt that exist. And there are so many. You can just go to Google and just search for language bindings for Qt, and this is going to be the link that you end up with. So I want to show you an interesting fact we noticed the other day. If you look at the PySide download stats from the Python package repository called PyPI, you can see that it's 14 million. I compared it to the other popular Python GUI frameworks, and PySide was far ahead, which kind of means that PySide is probably the most downloaded Python GUI framework. That's absolutely crazy. This is quite followed by PyQt, which is the unofficial language binding with around 12 million downloads. So what really powers PySide? What creates this Python language binding? Meet the unsung hero, shiboken. Some of you might have already heard about shiboken. Some others might have no idea about shiboken. So shiboken is the language binding generator, specifically the Python language binding generator that we use. It is comparable to other language binding generators like PyBind11 and Nanobind. PyBind11 and Nanobind, some of you might know it. It's a very popular Python language binding generators for C++. It's very popular in the C++ community. What exactly is the shiboken advantage that you have as compared to traditional approaches? So traditional approaches like JNI, Swig, CPython, etc. would require you to modify your source code by introducing some macros, directives, which kind of leads to extensive boilerplate code. So, which is pretty bad. Then you will also have, for example, like tools like PyBind11, you have some certain amount of manual binding maintenance, in the sense that in order to expose a class and all the methods in that class, you literally have to specify all the methods that you want to expose to Python. And all these traditional approaches are also framework agnostic solutions. They are not specifically made for Qt, for example. On the other hand, if you look at shiboken is a non-intrusive binding. You don't have to modify your source code. It automatically adapts to new Qt features and classes. To expose a C++ class using shiboken, the only thing you have to specify is the class name. You literally don't have to specify any of the methods of the class. They automatically get exposed to Python. Shiboken also has a lot of Qt-specific optimizations. For example, conversions from Qt containers to Python sequences. My talk is really not about shiboken, so I don't want to dwell too much into this. But if you can go check out the documentation of shiboken, it's really easy to use. Anyway, shiboken has been existing for more than a decade right now. That kind of means more than 10 years of making C++ love Python. Okay, that's a weird phrase. I'm going to rephrase that. More than 10 years of creating Python bindings for C++. And over the years, we have had support for a large number of C++ features like smart pointer support, different C++ containers, modern C++ type, and so on. But the fact is that creating a language binding tool is hard. Creating a language binding itself is also hard because you have to create a wrapper layer in between that specifies, okay, this is a C++ class, I want to expose this particular C++ class and all these methods to Python. This is the case with shiboken, PyBind11, or any other language binding that you take. So imagine creating a language binding tool for multiple languages. This is going to be very hard to maintain. So time to explore option 3. Option 3, unified frontend and multiple backends. What does that mean? So the idea here would be to use QML as a universal frontend, because I feel that we have really transcended from the period of using Qt widgets and then moved on to developing applications with QtQuick and QML. So in this particular case, you will be using QML as a universal frontend and then seamlessly connect it to the multiple backend of your choosing. So choose any backend language you want. This also really creates a lower entry barrier for the users because they can easily connect their backend and expose data to the QML or QtQuick frontend. With that, I would like to introduce you to Qt Bridges, future of QtQuick development. The idea behind Qt Bridges is to make QtQuick feel native in every language, but also enable a simplified and automated processes for signal slot connections, property system definitions, Qt-specific patterns. What that actually means is that with Qt Bridges, our aim was to focus more on the logic rather than the Qt nomenclature or the Qt jargon, in the sense that you reduce the knowledge that you might need about, for example, Q object, Q meta object, signal slot connections, properties, systems, and so on. So the idea is that you can create a backend in a language of your choosing, and then easily expose data back to QML. In the initial subset of Qt Bridges, we will be supporting 5 languages. Firstly, Python. You might be wondering right now, if Qt Bridges for Python is going to exist, what does that make of PySide? What is the difference? I'll show you that in the next coming slides. The other languages that we support are Rust because of its amazing memory safety. There's Java because it's an amazing enterprise system. C# because of Windows and its connection to the .NET framework. And then Swift because of iOS. Since I'm the Python guy, I deal with creating Qt Bridges for Python. I want to talk about some of the benefits that you have with Qt Bridges in Python. You can easily expose Python class instances directly to QML as singleton in order to expose data from your Python data model, which is in your Python backend code. You can easily, seamlessly call Python functions from QML. And then most importantly is to reduce the Qt jargon that is required in your end user code, like at slot, at signals, all the QML element stuff won't be required anymore. Let's see how that looks like in practice. So the idea is to write natural Python code with Qt Bridges. You will have a new Python package called Qt Bridges, which will have this function called AutoQML Bridge. The name of AutoQML Bridge is not fully finalized yet. So anyway, there is this, imagine for this example's sake, there is a Python class str model, which has one method called add string. Doesn't add anything, it just simply prints the string that you want to add. In order to register that str model class with the QML engine, what you need to do is to create an instance of that and then pass that to AutoQML Bridge. With that, you will be able to use that instance that you created as a singleton in QML. So using it directly in QML would look like this. So in the QML side, you have a text field where you enter the input string, and then the button where when you press the button in the on-click side, you basically see strmodel1.addString, which basically gets the Python backend gets called. And as you see in the Python backend, there is no Qt jargon involved. There is no at slot, Q object. There is literally nothing. And as you see from the QML side here in the on-clicked field, you see strmodel1 because that's the first instance that you created. So for more instances, you will have a more incremental naming. But that's not your main use case. Your main use case would be to expose data to QML. For that, let's take the same example. You will have to implement a data method inside your Python class. In this particular example, I'm actually returning a set of strings so that I can visualize those strings as a list view in QtQuick, so that I can actually use it with a list view item from QtQuick. That's the only thing that you need to do. And for different kinds of data, depending on the type data that you return, you can literally use multiple types of QtQuick items. For example, if you return an SQLite object, it basically displays it as a table view. So yeah, there are different kinds of data that you can return with Qt Bridges. So how does this look in comparison to PySide code? The exact same thing you can also do with PySide, but the code is much more. You can see that here. The same thing when you do with PySide, it kind of looks like this. in this particular case, in the case of PySide, you will need to know what QAbstract list model is. You will need to know what QML element is. You will also need to know some of the functions within the QAbstract list model that you need to override in order to expose those the data that you have back to QML. So yeah. So then now you might have the question. So does that mean that I do not need PySide at all? You still need PySide to work with Qt bridges because you still need to create the Qt event loop. You need to initialize the QML engine and then you need to load the QML file. But then this code is basically something that you can, copy paste for multiple applications that you have. But at the same time, another advantage of using PySide is that imagine that you have a QtQuick item like QtQuick painter item, and you want to expose that to QML, register it as a QML type, then you need to inherit from that item and then expose directly from PySide. That's the only way to do it. But for when you need to expose any form of data and then visualize that with QML, Qt bridges is much more easier. So now let's look at some of the real world use cases. Now that you get the idea what Qt bridges is, let's look at some of the real world use cases with Qt bridges. Firstly, rapid prototyping, because you're doing it in Python and you have access to the extensive network of libraries with Python. You can simply write your end user code fully in Python without worrying about the Qt jargon and then expose the data back to QML. Visualizing AI or ML predictions. Imagine that you have a machine learning model at your backend. You make some predictions and then you want to visualize them as a dashboard or some real-time data. It's again fairly easy. The only thing that you need to implement is this data method and then pass that back to QML. Fairly easy. And then combining in the extensive network of Python libraries with sleek QML front ends. So many more benefits. But you might be wondering right now, I'm a C++ developer. Why should I care? Why should I care about multi-language support? Why should I care about PySide, Python, or shiboken? Let me tell you some more benefits that, let's say, from the Python point of view, what you get as a C++ developer. Make your application scriptable for easier extendability. So what you see here is a Qt C++ application, and which is a text editor. And inside the text editor field, what you have is Python code. What you write is basically Python code to control the characteristics of the text editor itself. So what this basically means is that you are actually embedding the Python interpreter within your Qt C++ code, and then which easily gives you access to write Python code within your Qt C++ code. This is something that shiboken provides you, and this has been something that has been existing for many years in our repo. As an example, it's called scriptable application. Go check it out. And this is an application, or this is used to create plugins for your C++ applications. Python plugins for your C++. Some of our customers like Autodesk, Siemens, etc. are actually using this for having Python plugins that attach to their C++ applications. Based on this idea, the scriptable applications idea, where you can create Python plugins for your Qt C++ applications, and also taking inspiration from shiboken, we decided to take it one step ahead by introducing dynamic bindings. Scriptable applications made easy with dynamic bindings. So what I mean by dynamic bindings is that dynamic bindings provides you the ability within your C++ code to directly register your C++ types with the Python interpreter. Very easily. You don't need bindings, you don't need PySide, nothing at all. With that, I would like to introduce you to Qt Python scripting. Qt Python scripting will be a new module that will be available in 6.11 as a technical preview. It's not a Qt for Python module, it's going to be a Qt module. And let's see how that works. So with this new module, you will have a header file #include Qt Python scripting, which will give you access to this Qt Python scripting engine. You create an instance of this Qt Python scripting engine and register the type that you want. It could be any C++ type, but for the sake of this example, I'm using QPoint. Then when you do the register type, it immediately makes the type QPoint available to that of the Python interpreter. And then you register the constructor of the class so that you can initialize the instances within Python. You register some of the methods within that a C++ type to Python. For example, in this case, I'm registering X, Y, and Manhattan length, which are like getters there. And I'm also registering two setters. This enables you to write Python code within your C++. In this particular example, I'm writing it as a string, but then you can also fetch this from a file as well. So as you see here in the Python code there, you don't need PySide. You don't need to create any Python bindings. That is immediately available. QPoint is immediately available to the Python interpreter, which gives you access to the entire network of Python libraries as well. So since I registered QPoint and also the constructor, I can create an instance of QPoint. I can set y to a new value because I've already registered the set y setter, and then I can print that in Python. And then I do engine.execute script, and this is going to execute the Python script basically. So who here knows about Qt script from the Qt 5 times? Okay, super. So you might be wondering that if this is similar to Qt script. It's pretty much similar to Qt script, but the use case is different. Qt script was for ECMI script or JavaScript, I remember, but which was actually changed in favor of QJS engine. Qt Python scripting is basically for Python so that you can easily create plugins. Imagine this to be like Visual Basic for Microsoft tools. And there are so many more benefits that you can have with Python. So when you think about these other languages like Rust or C#, you get C#, you also get to tap into the potential of these other languages fully as well. Qt framework is not the only framework that is investing in other languages. If you look at Flutter is a very popular Python library these days. It's actually the Python counterpart for Flutter. It has around 4 million downloads. And then there is Eel, which is the Python counterpart for Electron with around 3.8 million downloads. There is another framework called Tauri, which is again super popular among the Rust community these days because your backend is in Rust. They are also investigating into creating multi-language bindings for Tauri as well. Just check out the issue 4670 for that. So looking forward, we already have a strong foundation with PySide and shiboken. The future vision would be to have multi-programming language support as the core strength with Qt bridges, unified front-end with QML and QtQuick, write backend code in a language of your preference, and focus only on the business logic. Do not worry about the Qt internals. This also means a very low entry barrier for developer who wants to get used to Qt and expose their data back to QML. So coming to the final summary about the things that we discussed, or things that I said during the course of this presentation, is Qt Bridges, which basically invokes multi-language capabilities for Qt applications. PySide and shiboken, which is like existing for many years, production-ready tools with years of maturity. And Qt Python scripting, which, as I mentioned, will be available as a technical preview in 6.11, which enables you to add dynamic scripting with Python, enables you to easily create Python plugins for your Qt C++ or any C++ applications in general. With that, I would like to conclude my presentation. Thank you so much for listening. If you want the slides, you can go to that following link. I'm sure that many of you would have questions about what Qt Bridges. Find me after this, or find the person who hosted this room is actually the team lead for Qt Bridges and Qt for Python. His name is Christian. Find him as well. So